Good morning, everyone, or afternoon for many joining us in other parts of the world. I'm from Texas today, so it's noon sharp here. Thanks for giving up your lunch hour and joining us. With me today, first, I guess I should introduce myself. I didn't do that. I'm Mike Lee. I work in sales and marketing for Voyancy. This was a little bit of a bet that I had with some of the software team members. Can a salesperson learn Dynamo? And the answer is yes, and we figured we'd share. Joining me today, I've got one of our lead software engineers, Fran P. I call him the professor. We're great friends, not only because we enjoy working together, but also share a love of cats and playing cards as well. So thanks everyone for joining us today. I'm gonna go ahead and kick it off. Today's session is learning Dynamo. It's so simple, a salesperson can do it. And we're gonna just get hands-on and start here. Before I jump in though, I wanna talk about some of the basics. The first thing I wanna make, before we even start with coding or anything very complicated, is really understanding what code is. One of the things I hear a lot is that software is really, really difficult. What language should I start learning? Is it Python? Is it C#? Should I learn something a little bit more related to the systems and tools and equipment I work with on a day-to-day basis? I think my answer is I would start with logic. So I'm going to start with a really good example here. I know this, if you're thinking you're coming to an architecture webinar, and I'm going to start talking about socks today. But first, I'm going to give you a truthful statement. What if I told you my socks are not red? The next thing I'd ask is, what color are they? Are they gray? Are they blue? Are they not green? Could they be red or blue? The last question, am I even wearing socks? I'll give you the answer in a minute. It may not surprise you based on that last one. But really, when you start to think about this concept, what does it mean to be not red? So to understand this, we use what are called logical operators. This was really, really interesting to me in university, so I may be lying to say that I have absolutely no background in this kind of thinking, but it really helped me take the concepts of developing programs, applications, automations, and start to understand it in a way that made sense to me. Typically, when you start talking about symbolic logic, and I'm not going to give you a full university course today, we'll just hit the high levels here. But typically speaking, you've got your 5 symbolic operators. They're pretty simple. The first is not. My favorite movie, Borat, he says this all the time. Not Q means it is not Q, but not red. It could be blue, it could be green, and we'll get into this a little bit deeper. But the other ones are very, very simple to understand too. This isn't, a very complex kind of idea. Symbolic logic's been around for years and years and years. So you have the AND operator. You need both things for it to be true. Either one could be true, that's your OR. If P, then Q. If one, then it implies the other. And your equivalency, P is Q. Ooh. I am sorry, technical difficulties today. Well, my photo has disappeared, and that's okay. It was a photo of Maury. I wanted to talk about truthfulness before we really get into code. Understanding the concept of truthfulness is extremely important to understanding how to create software programs in the first place. Before you even get into something that looks like this, that's terribly complicated, really taking that concept, is something true or is something false, is going to be very, very important for you. So simple. You're probably kind of confused now and taking a look at this, and I've talked a lot about logic, about my sock colors, about all these things, and you're saying, how do I get to this point? That's really what we're going to teach you today. The first thing though is there's a couple different ways that you can create software programs. This is the one that most people are probably most familiar with. If you've seen The Matrix or any other movie, you see lots of zeros and ones. Maybe, depending on the language you write in, there will be different colors and lots of different statements here. Even if you don't know how to code though, you can take a look at this code and you can probably infer a couple things here. The first is, hey, we're looking at some documents, some wall references. It's pretty basic that way. Now, I'm not a real expert and I didn't write this, Fran did, so I can't tell you exactly what it does, but it's not as scary as it seems. It's just like learning another language. But beyond textual-based programming, we have visual-based programming. Uh, Really, the big difference is you don't need to simply write things out. You don't need to be as worried about making sure the commas and periods are in the right place. Visual-based programming is interactivity. You have different elements depending on the tool that you're using, and you combine those elements in different spatial ways in order to build logic. One of the downsides to visual-based logic is that there isn't that much opportunity to simply write out your logic like you can do in a symbolic manner. We already talked about textual, but essentially you're learning a new language. There's lots of them out there. Today we'll talk about a couple before we get into some of our hands-on examples. But both of these can be used to create programs. They both can be diagrammed out symbolically and represented with a mixture of symbols. So what is visual-based logic? Well, it looks something like this. Each one of these boxes would be a different logical operator or maybe multiples. And you can see they connect each other based on what your workflow is and what you're trying to do. So we're going to really get into the meat and bones of the presentation today. These are, to me, as I was learning Dynamo, some of the key concepts that I really needed to wrap my mind around first before I even started writing down logic or figuring out how to do things with the tool. The biggest thing I want you to take away today is the difference between nodes and wires. We'll look at a couple nodes in a minute, but nodes are an object and they perform an action on data. Maybe it's adding it together, it could be a multiplier. Those are really simple ones. Fran will talk really deeply though on ones that you can use on a day-to-day basis. Wires are the connections between your nodes and they're shown visually as blue lines. So you can't really mistake the two. We just looked at the picture of visual-based programming a minute ago. But if you're thinking back, you could see the wires, you can see the nodes. Wires connect input and output ports. Those are on the side of the node, and data flows just like you would think. It flows into the input. The node performs some type of calculation or other data manipulation, and then it's going to transmit an output of your data from the output node via that wire. So what is a node and what does it look like? Here's a screenshot of one that you'll see in Dynamo. And I've diagrammed this for you. I'll kind of skip over this because it's pretty high level. And one of the things I really like the most about Dynamo is how simple it is to use. At the top, you've got your name, pretty simple. You've got the main body of the node. If you click on it, it presents options. As you can see, you've got your ports on your left and right. Number 3 here, number 3 here. And then you've got your lacing icon. That's how you match list inputs. We'll get more into that later. I don't want to complicate things too much up front, but we'll talk about that a little bit at the end. The last piece is some nodes have default values. You can use them or not use them. But if you right click on an input port, it'll tell you what that is. Nodes can have different statuses. Just like in many other software programs, if you've got a red node, you've got an issue. Red nodes, there's an error. Yellow, those are showing warnings. Maybe you didn't select something like in this example. Nodes that you're actively working on are a dark gray title bar, light gray background. If you've selected a node, as you can see, you get this blue selection ring. And you could see these, again, just another example of the wires connecting different nodes. If the node is frozen, it's transparent. And what that means is basically that node isn't doing any calculation or any action on the data that you're working with. So before we talk too much about how to use Dynamo and improve your workflows, I want to talk about basic data types. Data types can be different in the different types of tools you're using. In Dynamo, though, we've got 3 different ones that are really important. And I'm actually going to go from right to left. I talked about truthfulness a little bit earlier, but this is the Boolean concept that's incredibly important to understand. Statements can be true or false. There isn't really a medium or in between of those, right? It's not A decimal number, you've got one or the other. 0, 1, yes, no, true, false. In Dynamo specifically, true and false are the only values that are used. So just keep it in mind. It's not a 0 or 1. It's not a yes or no. It's true or false. The second piece of data that's important to understand it's really simple too, numbers. I think, we have all worked with numbers before. You can have two types of numbers in Dynamo. They can be either integers or decimal-based formats. You simply write them like any other number using Arabic numerals. The last data type that is extremely important, and this is probably the most complicated part if you're unfamiliar with what a string is learning what strings are. So words, textual-based information, we call those strings. But we're also occasionally in Dynamo using actual code in order to write some of the logic out that we are using. So the important thing to keep in mind is if you have a string, you really need to delineate it from some of from your other code. You'd use that, or you do that by using quotes or double quotation marks. So after you understand data types, there are two data structures to understand. And for some reason, my slide's not advancing. Let's see why. Once you've understood the three data types, you really need to understand two different data structures. So a list is the first. I've mentioned that previously, and this is a concept that Fran's going to keep taking later. Lists are composed of ordered values. It's just as simple as making a shopping list. In Dynamo, lists use integers as index values. So if you have 10 floors in a building, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they're named different things, it's a similar concept here. The other type of data structure to keep in mind is a dictionary. Dictionaries are composed of a collection of key value pairs where each key is unique in each collection. More on that one later. So how lists work. We talked about this a minute ago, but you've got an index. You can see on the left, there's a list, and the first element is a 0 element. So I think this is probably the biggest takeaway today about how lists work, is it can be, you can start numbering a list different in different applications. In this case, it's kind of like the floor example I touched on a minute ago. I've lived in a few different countries before, both the US and the UK. And one thing that always confuses me if I've been in one area or another for one long period of time is trying to get to the right floor. In the United States, for instance, the ground floor like I'm on today would be floor number 1. In the UK, that would be floor 0 though. Lists are the same way. Your 0 element is the top element in a list. So that's the last thing to keep in mind here. So it is really, really simple to get started with coding. I showed you a complex example about 5 minutes ago, but this is a much more simple example. This program actually adds 2 numbers, and I'm going to point out a few things that you should be aware of here. The first is you can see this hashtag and a statement on the top. This is best practice to get into as you're learning to code right at the start. Give yourself comments, delineate them by using the hashtag, and talk about your work or your thought process as you're creating your code. So for instance, this program adds 2 numbers. First, we're going to define that number 1 is 1.5 and number 2 is 6.3. The next thing to do is start to add them together. So again, we've created a comment here that shows that the next line of code is adding 2 numbers. Last, we're going to print that sum out. And I know I may be speaking, or not explaining this very well right now because you're wondering what is a print statement. But because you can see my commentary, you actually really understand like what's happening without needing to be told. And really, this is key to keep in mind because you probably aren't working alone. You probably have colleagues that you want to work with and share your ideas, and hey, maybe they want to learn to code too. This is a best practice because everyone then is on the same page. It's very clear what your code is trying to do. It helps when you're debugging and trying to find the mistakes somewhere, especially if more than one person is collaborating on a single piece of software. So what is Dynamo? Well, I've talked about visual coding, I've talked about textual coding, and really Dynamo is the best of both worlds. With Dynamo, you have a simple visual user interface, but you also have the ability to enter textual-based code. So this means you can do part of it one way, you can do part of it another way, and even people who don't necessarily know how to write in software or in Python or another language, they can help work with it because it's visual and they can see what's happening. You can visually see where your data flows because the wires show the way. So I showed you a program a few minutes ago. That was just written in normal code language. In this case, this is what Dynamo would look like. The logic behind is the same. You've got number 1, it's defined as 1.5. You've got number 2, defined as 6.3. These numbers are attached to the input nodes. And then you've got a function here in this node, which adds X and Y together and gives you a value 7.8. So if you're a visual learner, it's obviously much simpler than having to figure out what order your different words go in. But at the end of the day, there's multiple ways to do the same thing. And it's a really important thing to understand in Dynamo when you're working with others, that you may do one thing one way, but others do things another way. So all being on the same page is really, really important because we're not always writing software programs to add two numbers together. So now we're going to get to the cool stuff. If you may have a little bit of background in Python or design script, this is what you can use Dynamo for. So this is what a generic code node looks like in Dynamo. There's a similar node for Python as well. You have to choose the right one. But you can add your code directly in here to create more complex workflows that you can't do with the default nodes. This is something I found incredibly cool. So if you've put your program together in visual syntax, Dynamo allows you to quickly convert it from node to code. So for instance, if you don't want to write the full line of code out, you can take a node, figure out what it needs to do visually, right-click on it, and then hit node to code, and it'll change it into textual-based logic for you. Here's the results. As you can see, we use the power of Dynamo to take this and turn it into a code block. And it says point 1 is taking points by coordinates with these 3 values. Now, once we have gotten very familiar with the basics, it's time to add Python into the mix. This is really just a tease of your future. Dynamo is extremely powerful with the native functionality from nodes, but eventually you may want to take this a little bit further and do something, maybe pull data from somewhere else that isn't as easy to in Dynamo. So if you're learning Dynamo today, I would put Python on the back burner and make it step number 2. That'll really help you increase your reach of what you can do with this tool. All right, Fran, I'm going to make you the presenter and I'm going to turn this one over to you. It is your time to shine.
Okay, thank you, Mike. I will share my screen. Can you see the presentation?
Yeah, and you're a little quiet, by the way. Maybe you need to shout.
Okay. Well, now we will jump to Dynamo in order to apply the concepts that we were seeing. To do that, we'll solve this problem. It's something really useful if you have been involved on BIM project, what I assume you did. But before that, we need to define better what is this problem, because on that way it's a little ambiguous. The definition that we have is collect certain sheets from the project and change the name. Well, what does certain means? I mean, here we could have different group of elements. In our case, certain is related with 2 conditions that we want to apply over our elements. We need to change the name in all sheets that has this category. In this case, sheet category will be a parameter, and we will do the same with that parameter, sheet series, and it has to contain this value. Well, finally, the name that we want to apply over our elements is a new name that will contain this prefix, and also we'll have uppercase in all the name. So right now I will jump to Revit. You should see Revit right now. I will open Dynamo. And I will create a new script. Well, it is your first time in Dynamo. This is the user interface. This is the workplace where we will build our scripts. Here we have the library where all the nodes are contained. The first part contains all built-in packages that we can use. And in this part, there are the packages that we could create or download. They are custom packages. Well, to start, I will start in selecting all the sheets on the project. We can do that on different ways. For example, one way that Mike mentioned was select model elements. With this node, you can go to the Revit user interface and select the elements you want to modify, or maybe you want to apply an action over them. In our case, we don't want to select sheets from the user interface. We want to use another way that allow us do it faster. And to do that, we will use logic. We will use a node that allow us select the elements using a category. This node is called all elements of categories. The input that the node needs to work is a category. We will use a node called category, and we will select the category sheets. Here. One thing that is important is the mode that Dynamo runs. Right now is in automatic. That means that in every action we do, Dynamo is executed. In that case, I will use manual because I don't want to execute Dynamo every time I do something. Okay, here we have all the sheets that we have in the project. If I go back, you can see that here are all the sheets we have. Right now, we have to filter the elements. And we have a condition that tells us that if the element has a certain sheet category and certain sheet series, is the element we want to modify. I go back to Revit and I will select one sheet. If I go here, we can see that the element has this parameter with this value and has this parameter with these values. We want element that match with these two values. So to do that, I will use a node called get parameter value by name. This node has two inputs. The first one asks us for an element or a list of elements, and the second one asks us for a parameter name, which is a string. So we can use the string node to write the word, or more, what is easier, double click and create a code block to create this string. I will use that way because it's faster. And between double quotes, I will write the parameter name that I want to read. In this case is sheet category. I will run this, and the result is a list of values. As you can see, it's the same number of elements that we have here. This is because each sheet contains this value in this parameter. This one has this category, that one has this, and the rest the same. So right now, we will compare this value with other value in order to know if values match. I will use a node called equals that basically is ask us for two elements or two values, and it will evaluate if they are equals. I will pass this list of values, and then I will write a word here. The word will be architecture, because this is a category we want to filter. If I run this, you can see that some elements match with false and other ones match with true. That means the first element don't have a category, doesn't have a sheet category that match with this value, but the second one and the third one, it is, and other ones also. Now, with this list of values, we will use this list of values as a mask. We will see now what is a mask. First, I will create this node. This node is really, really useful to filter things. We have to pass it a list of elements and then a mask that have, in this case, the same amount of elements. This is our list, our original list of sheets. I will connect it here. And then I will connect this list of booleans. What we will do basically is match every element of the list with this value. If it match with false, will be on this output, and if it match with true, will be here. So on that way, we'll separate, this is our first filter, we will separate the elements that we don't want to modify. Run. Okay, we have two lists. The first list contains the elements that has this value, and the second one contains those that don't have this value. We will continue with this set of elements. And now we will repeat basically the same schema. I will copy this here. But in this case, we don't want to read this parameter because we already read it. Right now, we want to read a parameter called sheet serial. I will run this, and okay, empty values. It is because possibly I wrote incorrectly this name. I will check in Revit. And yeah, I forgot an S. Okay, great. We have the values again. Now we know that we only want those sheets that has in this parameter this value. Great. I will connect this, and the value we want to have is 2000 plan views. Without the dash. Great. I will connect this to the filter variable mask. And now the list we will use is not the original list. It's the list we have filtered in the previous step. I will run, and again, so far we were iterating over those views, and our result have been this. As you can see, basically what we did so far is read values and filter elements with those values. We can achieve a lot of goals with this. Well, the next step is create the new values we want to add on these sheets. I mean, on the parameters that those sheet has. The sheet names in Revit are the concatenation of the sheet number and the sheet name parameters. For example, if I go here, well, we have the sheet name and the sheet number, and they are separated with this dash. So basically, the modifications we have to do are over these two parameters. I will start with the sheet number. As it is a new value at all, I mean, we need to use the old value to create a new one. I will read the current name first. I will run. Great. We have the current name. And we know that the new name will be basically the same, but with a word before. So I will create that word. In our requirement, we have this prefix. And then using a code block, I will create a new string that basically will be the concatenation of these two values. As you can see here, this list of values are also strings. You can check that every time with this node. They are strings, so we can concatenate them. I will create two variables. And when you write a word inside a code block without double quotes, Dynamo create a variable for you. So I will use, to simplify it, I will write the prefix here because will be always the same. And then I will add a variable. Great. We have this variable that basically is a container that can contain values. As values, I will connect the sheet numbers and run. Great. We have the new name we want to set over on the elements. I will do something similar with the sheet name. It is not the same operation. We don't need to add a prefix. We need to convert all the name with uppercase on uppercase. So I will copy this. I will change the parameter name and delete this. Dynamo has a lot of functionality. I mean, sometimes it's not enough. In that case, you can create new nodes, but for basic stuff related with logic, you could find functions here to run. For example, I know that exists this node. I will use it. The uppercase node is applied over on strings. I will connect my list with them, and we can see the result is also a list with the same amount of elements, but it has modified the value. At this point, we have the new values, and the last step is set them in the correct parameter. So there is a node that is really similar to this, at least in the name. It called set parameter by name. And that node needs an element or a list of elements. We will pass it our list, the one that has just 7 sheets. The parameter we want to modify is sheet number, and the new values we want to set are those. Now the same for the sheet name. The list will be the same. The parameter will be the sheet name, and the values will be those. I will reorganize a little bit this before run, just to clarify what we did. Our first step was collect all elements. Then we filter those that has this value on this parameter. Then we create a new filter. This time we filter them by sheet series. Almost at the end, we create new values. Those one. And finally, set new values. Great. I will run the script. Everything is okay. This node return a list of elements. I will go to Revit, and I will look for sheets, the sheets that we want to modify. Okay, for example, here we have one that was modified. If we check the parameters, both are correct. The same for this one, this one. If I look for other one different, for example, this, that has the correct category, but the sheet series is not correct, we can see that anything was modified. So we choose this project also because it's a really common schema. I mean, In this case, we are modifying sheet names, but eventually you could modify parameters in other elements with other values. But basically, you will collect elements on your project. You will filter them. Maybe you will read values in order to make decisions, and then you will set new variables on those parameters. I would say that for the not too much complex scenarios, more or less is the same story with different characters. I mean, this schema, you can repeat it many times on many projects, and well, you will be able to do awesome stuff. Well, I think that's all I have for the demonstration.
Awesome. Thanks, Fran. We really appreciate it.
Thank you.
It looks like we got just a single question today. If you want to jump on this one, though, Fran, I think this is probably one for you. Is Dynamo the best tool to learn to program with in Revit? And what is the first thing you should do?
I think it's a really good tool to start programming in Revit because, well, it's visual. And if you know the nodes, a lot of functions are described really well. Also exist other technologies you could learn, but I think Dynamo is a good first step. Before I start with Dynamo, I think it's really good if you have a good understanding about Revit, because normally you will work over Revit elements. For example, here we know that sheets is a category, we know what is a parameter, and if you understand more deeply how they work, it will help you a lot. Other advice I think that is useful is know about programming will help you a lot also in everything you do. But in Dynamo, of course, will be useful if you understand the basics, how to create an if statement, how to create a loop. Yeah, I think those would be my advices.
Thanks. Next question. How do you use Dynamo in your work today? Can you give us a couple examples?
Yeah, for sure. Well, when you learn at Dynamo, you will realize that you can do basically the same you do with Revit, but with Dynamo. And this is so good because you can work faster and think in different ways. In this case, we did a task that we have done several times in the past. We have applied Dynamo in large scale projects with plenty elements and plenty of people working. In this case, we're reading and setting values. This is something we do a lot, but also we have worked on projects when we have to generate geometry or place elements. For example, a really good project to practice is place elements on points on your project. For example, add hangers in pipes or add lighting fixtures in ceilings. Yeah, I think you can use it wherever you need.
Awesome. I think the last question we've got, it probably applies to both of us. How much time did you guys spend learning Dynamo? And I'll take that one first. I've been working on this for 5 to 6 weeks at this point. Truthfully, I did study logic in college and did a little bit of software on this side with some of the technical courses I took in engineering school. But I had never touched Dynamo about a month and a half previous. I was actually drinking beers with one of my colleagues and Fran, and he kind of challenged me, I think you can learn it. And I was like, yeah, I think I can. In 6 weeks, I can create simple things like this. Obviously, I'm nowhere near the professor's level, So Fran, you want to take that? How long have you been working with Dynamo, and what point were you comfortable with time-wise doing billable work?
Well, for me, I think it was a little easier because I knew programming before I started with Dynamo, but I think I was a couple of months until be comfortable with the language, with the environment, be able to sync with that. I think you have different levels of understanding. If you can practice, you will improve your skills always. I am still learning. Every day I learn something new. So it's an exciting path, I think, to follow.
Yeah, I love it. It looks like that's the end of the questions. So we're going to go ahead and end this. But before we all hop off here, you'll be getting an email later if you want to view this recording and view the slides as well. We tried to make the slides as referenceable material as possible, rather than just having lots of words. Of course, at any point, you're free to reach out to either Fran or myself. Our contact info will be included. And I think the most exciting thing from this is in 2 weeks, we'll be starting our first hands-on software workshop. So everyone in this call is invited to attend that in 2 weeks. In the email that goes out later today, thanking you for attending, there will be a link to register. The hands-on workshop, what we're going to do is ask you to come up with what's called a problem statement. So basically describe what you're trying to do with your work. We'll ask for submissions a few days before the webinar. That way we have some time to internally review, brainstorm, and think of some ideas. But each attendee will get a few minutes to ask questions, and we can help you brainstorm on some of the best ways to accomplish that with Dynamo. Of course, we also offer this as a paid professional service, so if you simply want to contact us and ask if we can do it for you, we're always happy to help there too. Again, thanks for attending. Fran, thank you for helping me out with this and teaching me in the last month. It's been really, really fun. Thanks, guys. Happy Wednesday.
Thank you.